Hello everybody, this is Todd Frazee, and we are starting out to set up the indicator standard base, part number 8DV4700301. We're going to set this up for machining on a 5-axis. We are going to use our dovetail system that we've been using, the 5th-axis brand system. So we need to draw the stock around here and define the proper dovetail on the face. So first we need to identify what face we're going to attach to. So it's typically your largest face, so it could either be this side or the opposite side. I'm going to elect for this side, and the reason being is that we can have continuous machining on all these chamfers and blends. They'll come out nicer than if those are done on a 3-axis mill. So we're going to get started with drawing our stock. Okay, first we're going to press the sketch button, and we're going to sketch on the top of our part, and we're going to draw a rectangle that's bigger than the part. Our stock size is a 2.5 inch by 1 inch bar, so in the width it's going to be 2.5, and the length we're cutting it is at 3.5 inches. So it's pretty close to the actual size of the part. We don't have a lot of material to remove on the edges. So to center this, we're going to take a line. We're going to go to the center of the outside edge of our block, and we're going to go vertical and pick. Then we're going to do an intersection relationship with the edge there. So this should be the center of our block itself. Left click on that line you just created, and let's turn it to a construction line. Make sure you have this triangular symbol, which means midpoint. Then we're going to draw a line from corner to corner on the sketch, and likewise we're going to left click on it and then right click on it to turn it to construction geometry. Then we're going to use the midpoint constraint and select on our two construction lines, and we should have it snap, turn black, and our sketch should be fully constrained now. I'm going to press finish sketch, and now we're going to do our extrusion. Now our 1 inch material, this model here is 800 thousandths in thickness. We're using 1 inch material, so there's not a great deal of material to hold on to this from the opposite side. So we're going to extrude, and we're going to put a little less material on this one than we did last time. We need to select inside the sketch and inside the perimeter of the plane we selected on so that it takes both of those. And we are going to extrude in two sides. And in the first direction, which is away from our part, we're going to go 10 thousandths. Typically I go about 30 to 40 there. And in the opposite direction, we're going to go the difference between 10 thousandths and 1 inch, which is 990 thousandths. It's going to default as a cut. We're going to change that to a new body, and so it won't merge the two entities together. We're going to hit OK, and then we're going to open our bodies folder, and we're going to change the name of body 1 to the part number. And then the second body should be stock. Right click on the stock body, and we're going to go to opacity control and make it 50% opaque or 50% transparent so that we can see our block, our finished model inside the block there, stock block. Alright, so let's add our dovetail prep. So if we look at the 5th axis specifications, we need to put this on the face, and so it's an 80 thousandths tall with a 10 thousandths edge break, 45-degree angle, and a minimum of 1/4 inch flat on either side to support. And if we look down at the next page, the proper dovetail profile needs to be 75% of the overall width of the block is their recommendation. So let's sketch on the end. And we can rotate our view so we've lined it up like somewhat like it would be on the machine. Okay, so we're going to start a line. We're going to start at the edge of the part, go horizontal, 45. You're going to go down a little bit, but don't contact the bottom of your model because it'll create a relationship. Try to go horizontal, then up again, angled in, and then to the opposite edge. You want to make sure that on the right and left side the points are black, which means they're attached and constrained, at least that they're touching. Now we're going to put in a series of relationships before we go any farther. So first we're going to say we want the land on the left and right to be equal in length. Looks like we got a little thing going on here. We're just going to move that back up. And we're going to reverse. There we go. Hopefully you don't have that issue. Anyway, as long as you still got an angle going in the right direction and this flat here, you should be fine. Okay, so now the next relationship we're going to do is we're going to make collinear. We're going to make this horizontal line collinear with the other one. And I got a fun little bow tie here I got to fix. Okay, there we go. Okay, we're going to put the equal relationship on the edge breaks. And then we're going to go ahead and dimension one of those. And it's 10 thousandths according to the drawing, if you recall. And the distance between the dovetail and the land is supposed to be 80 thousandths. Okay, and it flipped below. That's okay. We can fix that. And we're going to move the whole feature up. And then we're going to put a dimension between the dovetail and the edge of the block, and we're going to put 10 thousandths there as well. We're just going to be skimming a little bit of material off for this. And now we're going to put 45-degree angles. On both ends, which should give us that. And the only dimension we have left is the width of the entire dovetail. Now, this distance, again, needs to be 75% of the overall block. So what is that? It's 2.5 inches wide. And if we get out our trusty calculator, we're going to take 2.5 and multiply it by 75%, which gives us 1 inch 870. So we're going to take that dimension, 1 inch 807.50. Okay, we should have a fully constrained sketch at this point. We should do, because there's a padlock symbol there. And we're going to cut away the material that's on the edges of this. So at this point, you're going to hit Finish Sketch. We're going to go to the Extrude command. We're going to select the area we want to remove. It's going to go through all, and we're not making a new body, we're cutting, and we're going to flip the direction, and it should show in rendered in red what's being removed, and we hit OK. So we've now generated the geometry we need to simulate the stock material, and we're leaving as much as we can in between the bottom of the part and this land. Now, they do warn you about having this too thin, but if you have an extended tab that's really thin, in our case it's going to be very small rim around the edges, so it should be okay. This part is very rigid. All right, next we want to make sure we've saved. We're going to go to the manufacturing menu. Okay, so we're going to create a setup, and to do that we're going to need our model expanded and the body showing. We're going to right click, we're going to say we're going to do new setup. Now we're going to flip the part in the direction that we're cutting so that we're visualizing it that way. And we're going to select the model for our machining, which in this case is going to be the stock, not the actual part model. Okay. And then we are going to switch our orientation to Z-axis and X-axis. So we're going to pick what's normal to the X-axis, Z-axis, and then we're going to select a line that is on the X-axis of our stock. And it looks like we're going to have to flip the orientation of X to get it to go in the direction we want. And then we are going to select our actual origin, which is going to be a model box point. I've talked about it in the other videos. You can either set it here or here. I prefer to do the bottom. If you do that, you have to set your tools on top of 1, 2, 3 block and do a Z-axis shift of 1 inch. I feel that's more accurate, but it's different methods will work as long as you're within tolerance. Okay, we're going to go to the stock menu, and instead of, we're going to do relative size box, but we're going to add stock to all sides. And then we're going to add a little bit to Z. If we look at our stock height here, it says it's 990 thousandths, and our stock's actually an inch because that's what we modeled originally that we cut this from. And so we're going to do a Z positive 10 thousandths offset, which will bring us to a full inch. So that should give us 10 thousandths to skim off. Not much, but should be fairly accurate when you're talking bar stock. It runs pretty tight tolerance. If you don't get full cleanup, we'll have to do some adjustments on the machine. Then we're going to go to post-processor tab. We're going to call this program 3011. It's part 301. Is the last 3 digits of the part number. Operation 1, op 1 for the VF1 machine. And we're going to use offset 1. Should output 54. Okay, so we now have our stock set up. Let's change the name of it to op2 to be consistent. I'm sorry, op1 to be consistent. And there we go. Now we're ready to program. Okay, our first program is going to be to do a face mill. And we're going to run at default. Again, if you've loaded the new library, it should reflect these numbers. 5,000 RPM. We're going to select from our CR1 library tool number 1, and it should reflect these speeds and feeds, which were based off Kennemental's numbers. So 2,170 RPM at 50 inches a minute and 25 inches a minute for plunge rate. If they don't match that, you can just change the numbers. But if you download the latest library, it should reflect these numbers. We're going to go to the multi-axis tab, which appears like since the last time I recorded has moved in sequence. It used to fall after one of these other tabs. We're not going to do anything here because we're still doing a 3-axis move. We're going to go to geometry. We're going to just allow the default to be selected. We're going to go to heights, and we're going to go from stock top. We'll leave that at default. Our top height of machining is going to be the stock top, and we're going to end at the model top. So that looks all correct. We're going to go to the passes tab. Now you can select a pass direction. I like to go the length of the part with this type of mill, so I'm going to select that. Our pass extension, I would bump that up to be a little more than 1.5 inches. It should be a little more than half the diameter. So let's go 1.7, so we go a little bit farther. And we're going to do a 3-inch step over. Otherwise, we're going to get more than one pass with this cutter. And the material's 2.5 inches wide, and we have a 3-inch diameter cutter. So if we set it at 3 inches, it'll be a full 100% engagement, which is fine for this face mill. Okay, we're not going to do multiple depths. We're going to leave all the rest of that default. We're going to go on to linking tab. We want to make sure that this box that says keep tool down is selected. And then on our lead-ins, we're not going to do a vertical lead-in. We're going to put 0 there. And we can leave everything else at default. Okay, and so we get our one face mill cut. Only taking 10 thousandths off. Alright, now we're going to cut away the material of these lands. Let's see how wide that land is. So we're going to go to inspect, and it had to be at least 1/4 inch. We're going to go from the edge of, we're going to go the plane of the 10 thousandths flat to the edge of the model of the stock, and we have a distance of 313 thousandths. So a 1/4 inch cutter will not be wide enough to cut that. We're going to come in with the 3/8 cutter. So we're going to go 2-axis 2D contour, and we're going to select the bottom edge of the edge break on both sides. You want to zoom out, and you want to make sure that the arrows are on the outside of the line. Now right now it thinks you're using the face mill, so we need to go and select the correct cutter. We're going to go to our Sierra aluminum library. We're going to select the 3/8 flat end mill. We can take the default feeds and speeds, which should be 5,000 RPM, 40 inches a minute, and 20 inches a minute, respectively. Go to the multi-axis tab, there's nothing to select. Under geometry, we've got our geometry selected. Just make sure that the arrow's in the right direction. And we're going to go to the heights tab, and we're going to deselect stock top on both of these check boxes, and we're going to select model top as the top height. Now we don't want to cut to the selected contours. The selected contours puts our plane way up here, and it's just the bottom of our edge break. So what we want to do is we want to change that to selection and pick on the height of the land. That drops the bottom to where it's cutting the land itself. Okay, we're going to go to the next tab, and we're going to change compensation to wear in case we need to change that on the machine. We're going to leave most of this at default. We are going to do a roughing pass, and our maximum step over is going to be 80% of the cutter diameter. So a 3/8 cutter times 0.8 gives us a 300 thousandths step over. Not sure why the default is higher than that. We're going to do one step over. We're going to leave the smoothing tolerance alone. And now that we've added that, we can go up to here, and this box has appeared. This is our finishing, how much is going to be left for finishing. We're going to change that to 10 thousandths. We are going to do multiple depths. Our maximum roughing depth is going to be 0.375, that's one diameter, and we'll have a finishing step down of 8 thousandths, which is fine. We're really just wanting the finish pass on the bottom as a spring pass. I'm going to minimize some of this. We're going to rough at the final depth because we have enough flute length to do that. And we're going to use even step downs, and okay, we're going to hit roughing passes. On multiple depths, we needed to put one finish pass. I skipped over that box. Okay, we don't need to put anything for stock to leave or smoothing. or feed optimization. Okay. Now we're going to go to the next tab, the linking tab, and we want to keep our tool down between passes. Our horizontal lead-in radius isn't going to matter because we're going to put 0 here for the sweep angle. But our linear lead distance, if we're not going to do a radius first, needs to be at least half the diameter of the cutter. So 3/16 is the number we're looking for. So 0.1875. So let's just do 1.88. That's slightly longer. And the reason is cutter comp needs about that distance to engage. We're going to get rid of our vertical lead-in radius. And we're going to leave everything else at default. Let's hit OK, hit OK. Alright, so we should get several passes. Looks like we have 2 rough passes and 2 finished passes. Okay, next we're going to come in and do the dovetail cut. So we're going to do another contour, 2D contour, but we're going to switch to tool 19 in the library, which is our dovetail cutter. We should be able to leave everything at default. This came right from the manufacturer. Go to multi-axis, we're going to leave that at default. Our geometry, we're going to select the bottom of the dovetail V on both sides. Make sure your arrows are on the outside. Go to heights, we're going to go from model top, and we are going to go to the selected contours in this case. We're going to go to passes, we want to go to wear compensation. We're going to go to roughing passes, maximum step over. We're going to do 2 step overs in this case. And our maximum step over is going to be 0.02. So we're going to do 20 thousandths roughing steps. We're not going to do multiple depths, but we do need to go back to this step over here. And we don't want a 50 thousandths finish. We want a 10 thousandths finish step. So we'll end up with 3 passes coming in from the outside, coming closer. Okay, we're going to leave everything else there at default. We come back to the next page. We want to keep the tool down. We're going to go again 0 on the sweep angle, and our linear lead distance needs to be a little more than half the diameter. This is a 1/2 inch diameter cutter, so 0.26. We're going to have no vertical lead-in radius, and we're going to leave everything else at default, and we should get several passes that look like this. And we're going to move on to the 5-axis moves next.